Okay, so let's discuss about what is a cache and what is caching in detail in this video. So what is a cache? Cache is basically a temporary storage, and storing it in a different ways or in a different mechanism, we call it as caching. Okay, so here it can be a data in a technical terms, or in a day-to-day life we also do it in many different ways. For example, we can just take one example where we tend to put the used clothes on a chair, or we just hang it over so that we get it quickly on the next day, right? And after 2 to 3 days we just push it into the washing machine or to just get it cleaned. But the temporary storage, whether it's a chair or the hook, is never empty, because we just keep on adding just frequently used clothes for the next day use, right? So this is a simple example of caching, where we just put the things temporarily over some place so that we get it quickly in the next time, right? In the same way we do it here technically, where we add or store the frequently used or the most relevant data in a place where that can be quickly accessed. So that is what caching means. So here, by definition, caching means storing data temporarily so that the next time you need it, it is fetched in a much faster way instead of going all the way to the main source. It may be database, API, or the disk. Okay, so this is what basically a cache and what is caching. Now let's see what are the different mechanisms or the ways we do it technically. Okay, so here the first caching we have is the browser cache. So that happens on the client side. So here, what is a browser cache? So here the data or the frequently used data for a website is stored within the browser. So let's take an example of YouTube. Okay, so when you open the YouTube for the first time, YouTube will download all the required data for this website, like the small icons or images that are static. For example, the icon of the YouTube, or these icons of all the tabs, like history has this icon, home has this icon, right? So these icons will remain constant for whatever time you just open the YouTube, right? So those things will get cached here in your browser. So you can just check that over under the cache storage. So in the developer tools, if you go under the application, and here under the cache, you can see all these data get stored, all these icons get stored, so that whenever the next time you open the YouTube, you go to this domain, so it will not download these icons again from the main server, but it will just load it from within your browser. So other than that, whatever the data that is related to a per user, that's also gets stored in the browser cache. Okay, so this browser cache is highly private to that user or for that user session. Okay, so next we have is the CDN. So what is CDN here? CDN is content delivery network. So these are nothing but again servers that are placed very near to any of the your location. So one best example of the CDN use is the live streaming. Okay, so let's say there is a live streaming going on in Mumbai, and that live stream just is getting watched across the globe. Okay, so in that case, if you have observed, everyone who is watching that live stream across the globe will get the stream at the same time. Everyone will be watching it live, or the moments captured on the live stream will be same across the globe, and that is possible because of the CDNs. So whenever the recording gets recorded on the live stadium or the place, that gets that will be sent to the all the servers present across the globe, and from those servers it will get served to all the users at the same time. But let's say if CDN is not there, if this technology or this caching is not there, then what will happen? The users who are sitting closer to the Mumbai will get to see the live match faster, or they will be ahead than the people who are watching from the United States, because of the distance of the data that needs to get traveled. So this issue is resolved by the technique of the CDNs. So the moment when a clip of 2 to 3 seconds is captured from the live stream, that will be quickly sent to all the CDN servers across the globe, and from those servers it will be served to all the users. and due to that, all the users sitting across the globe will feel that they are watching live, but it is always around 5 to 6 seconds behind than what actually happening on the ground. Okay, so that's the CDN and the browser cache which are implemented on the client side. Now what is the difference between these two? So here, first of all, the difference is in the location. The CDN cache is stored on the CDN servers, and that is served to millions of users at the same time. That is common to all the millions of the users. But browser cache is stored inside the user's browser or the inside user device, so that is private to that user. Okay, and the next major difference here is the purpose they both serve. For example, here the CDN serves the purpose of reducing the distance and the load on the origin server or the main server. So with the CDNs in place, the load on the main server get reduced, and millions of users at the same time get served and in the most faster manner from the nearest servers. But the role of browser cache here is to reduce the repeated downloads of the static files, right? So that's the difference between these two. And the next caching we have is the application side or the server side caching. So in the server side caching, there are two ways that are done here. The first one is in-memory cache, and another one is the distributed cache. So let's here first discuss about the in-memory cache. So in-memory cache is storing the cache or the data within the memory of the application. So let's say a service is running on a machine. Then here, whatever the cache we will be storing, that will be stored in the memory of that machine itself where the application is running. Okay, so here that will be stored basically on the RAM of that machine. And here we will be using many popular libraries like Caffeine, EHCache or Goava cache. So these libraries will help us to store that data on the machine, and that is in the RAM of that machine. Okay, and this is mostly helpful for a smaller or a monolithic application where we don't have many other services, or where we have the application running on only one machine. Okay, but if we have a microservices, then this technique will not help, because when we have multiple instances of a service, then if we store the cache on the memory of the machine, then the cache will get missed if the request goes to another machine, right? So that is one of the drawback. And also, if that machine goes down, then the whole cache will also removed or it get deleted, right? So we will be going with in-memory cache only when we have a monolithic applications. Okay, or when we have the application running on only one machine. So the next here we have is the distributed cache. So distributed caching is used in the microservices architecture when we have multiple services and each service have multiple instances. Then in that case, we will have a centralized distributed cache where we'll be storing the cache on another database like Redis. So here, how is it different from the normal databases? So it is different on different levels. For first one is the location where it is stored. So here on the normal database, the cache or the data will be stored on the disk of the machine, right? But here on the Redis database, it will be stored in the memory, that is on the RAM. So the read and write are much faster than compared to the traditional or the normal databases. And the protocol that is used between the transmission of the data from the server to the database is much more efficient when compared to the Redis and the other databases. So here with the distributed cache, we will be having one single instance of the Redis or the whichever database we are using as a cache, and then that will be connected to all the different services or the different microservices, so that every microservice will have access to the same cache. Okay, so these are the two ways where we do caching on the server side. Okay, so we discussed about the client side caching and server side caching. Next, let's discuss about the caching within the database, within the main database. So here within the main database, we have three different types of caching that can be seen. So the first is within the database internal cache, where the database itself cache couple of things like the repeated or frequently returned rows or the index pages. So this is done on the RAM of the database, that will be internally done by the database. That's the one type of caching within the database. Next, here we have the query cache. So with respect to the query caching, this is something in control of the developer or the database administrator, where we can configure this query cache. So if we enable the query cache, then all the select queries will automatically get cached in the database. So for that, we can specify a couple of amount of memory, and within that memory this data get cached. So here for example, let's say we want to get all the students who are from Delhi. Okay, select star from students where city equal to Delhi. When we execute this select query on the database, it will return us a couple of rows. Okay, so those rows will get saved into the cache. Okay, so here the data is constant. Whatever the data got returned at the first time when the query is run, that gets saved. Okay, but after some time, if there are additional students got added into the database who are from Delhi, then those students will not be there in that saved data. So that cache will get invalidated or it's outdated, right? So in that case, again, that will get deleted and the new cache will get stored in the next time. So due to this is a very performance intensive from the database perspective. So that is the reason this has been removed from from MySQL 8 and the higher version. But before MySQL 8, this feature was there, but currently it is still present in the MariaDB. Okay, so that's the another kind of caching, that is query cache. And the next one, and the very important one, is the materialized views. So what is materialized views here? So let's say we have multiple tables. Let's say student table is there, marks table is there, and performance table is there. So and we have a query that is going to be executed at a time on all the three tables, and then finally we are getting a result for all the students, okay, or for each student. So in this case, we needed to run this query every time for every student. Then that is highly performance intensive, right? So due to this reason, what we can do, we can create a materialized view, that is nothing but a separate table storing the result of that complex query. Okay, so that result gets stored in a new table, a physical table, and then from the next time, whenever we needed that data of that complex query or the result of that complex query, instead of running the whole query, we will just query that new table and we'll get the data, and that can be frequently refreshed whenever we needed it. So with this, that complex query needed to be run only once, and with that we'll get a higher performance, right? So this is a materialized view, and this is highly used in many databases for the faster query responses. Okay, so this is about the database caching. So that's all about the caching at different sides, that is client side, database side, and the server side. So next, let's look at the different strategies that can be used while caching the data. Okay, so let's discuss about the different caching strategies in this video. So here first, let's start with the cache aside strategy. So where do we see this strategy in real life? First, for that, let's take an example of Amazon. So here in Amazon, let's say you want to buy an iPhone. So here what you do, you'll search for an iPhone 15. Okay, so when you search, you will get these iPhone options, right? And if you just click on any one of them, okay, so here you will get the details of this iPhone, right? Okay, so now this is not just me who is doing this. This is done by millions of or billions of other users also doing the same search for this product, right? So in this case, it is not ideal that the application is again and again going back to the database and fetching these details and returning back, right? So this is where the first strategy comes into picture, that is cache aside strategy. So what does this do? First, the application will search for sends a request for a data to the backend or the server. So the server will first check the cache. If it is not there in the cache, the application will to the database, it will fetch it, and it will first add that data into the cache, and then it will return back to the application. So now from next time onwards, when the request comes again, so this time the application will again check the cache, and this time it will have the data, and it will directly return it from the cache, and it will not hit the database. So this is, by this, the performance of that API gets increased. So the response time will get decreased, right? Now this is very significant when we have millions of users or millions of users trying to get the same product. Okay, so I hope you got the first strategy, that is cache aside strategy, where first the data is checked in the cache. If it is not there, then the application is going to get the data from the database, and then it will put that into the cache, and then it will return back to the client. And from the next time onwards, it will be returning back the data from the cache. So this is the cache aside strategy. The next strategy here we have is the write through strategy. Okay, so in this strategy, first, whatever the data that is coming from the client, it will be first stored in the cache, and then it will be stored in the database, and only when it is stored in both the places, then only the response will be sent back to the client. So this is happening synchronously. Okay, so it is made sure that the data is stored in both cache and the database. So if any one of the place it get failed, then the response will get failed, or the client will get an error. Okay, so it is made sure that the data gets stored in both the places. Okay, and why this is important? So let's take an example here. So now let's say now I have decided to buy this iPhone. So in this case, now what I will do, I'll just add this to the cart. Okay, so adding a product to a cart is a very significant or an important functionality of this application, right? So here the application cannot miss this data when a user adds some data to the cart, right? Because let's say when I have added the data to the cart, and then now if I refresh it, and still if you see there is a data still added in the cart, right? But let's say if we have not stored that, let's say if we have only stored that data into the cache, and we have asynchronously stored the data into the database, then let's say that asynchronous communication went down, and that cache also got down. And in that case, if I refresh it, then the cache, because the cache got down or it got removed, I'll miss the data into the cart, right? So to avoid this, what we are doing here, we are adding the data at both the places, and then only we are sending back the response. Okay, so with this, even if the cache goes down, the data will be still present in the database, and we will be able to see the data or the product in our cart. So that is the second strategy here we have, that is the write through strategy. Okay, the next strategy here we have is the write back or write behind strategy. So in this strategy, what happens? It's an opposite of the previous strategy, where here the data will be stored asynchronously at both the places. Okay, so first, because for the quicker response to the client, first the data will be stored into the cache, and then the application will asynchronously store the data into the database. And this is suitable for the scenarios like adding the product to a wish list. Okay, so let's say if I go to this product, and here let's say I just want to add this to the wish list. So adding something to the wish list, here I need to log in. I'll not be logging here, but adding something to the wish list is not that significant than adding the data or product into the cart. So for this scenario, to get a quicker response back to the client, what we can do, we can go with the write back or write behind strategy, where the wish list is first added to the cache, and then asynchronously will add it to the database. Okay, so that's the write back or write behind strategy. Next, and the final strategy here we have is the read through strategy. So here the read through strategy is very similar to the cache aside or the lazy loading strategy, but the only and the significant difference is that whatever the data that will be added to the database, it will be done by the caching system itself. So what do I mean here? So when let's say when let's say we have searched for a product, and here it will be directly searched into the cache. The application will search, or the server will search that into the cache. Okay, and if it is present in the cache, it will be returned back. Okay, but if let's say the data is not present in the cache, then Here the application is not going to fetch from the database, but the cache itself or the cache server itself going to call to the database, and it will first get it, it will store it in the cache, and then it will return back to the application, and the client will get back the response. Okay, but here in case of cache aside strategy, it is the application that was going to make the call to the database and then do these operations. But here it is the cache that is going to do this operation. That is a cache, the mechanism or the cache database is going to do this operation. So here there is 1 or 2 network calls will be reduced in this case, but here there will be 1 or 2 network calls more than the read through strategy. So this can be either one of them can be implemented according to the requirement. Okay, so I hope you are able to understand these 4 important caching strategies that are used widely in the enterprise applications.